think. Can find, I think it should be here. Yeah, yes, that's correct. All right, thank you so much, guys. I think since the chapter is on functions, we're going to start with some of the easiest concepts. And the easiest concept of when you take a function, for those who have already understood what is a functions, is defined on a set, and then it takes its input from a set, and then it takes the input, transform it, is like a machine. It transforms the input into an output. So let's first start by, before that, the question is that what is the input? Uh, so we need to define a set, and I'm going to ask you, can you please tell me what is a set? If for those who heard of a set, tell me what do you know about a set? Yes. Please tell me what is a set. Hello, are you guys hearing me? You can just talk. You don't need to raise your hand. What is a set?
Is it a reference to the domain and range, sir?
Sorry.
Is it the reference to the domain or range?
Yes, I'm
A
asking
set
you
of
what
a
is, yeah, a set. How can you define to a normal person in the on the road? Like, let's say, how would you define what is a set? Yes, it's referring a set. I mean, we are in talking in mathematics. So what I mean by a set is in the mathematics sense. Okay, a set is basically just a collection of some objects that are not the same. And those objects, usually they are called elements. Now, those elements, depending on where you are, if let's say you are using set of numbers, then those elements are numbers. If you are using set of vowels, those elements, they are the vowels. If you are using, let's say, an empty set, who can tell me what are the elements when the set is empty? Tell me what are the element on the empty set. An empty set is, okay, first let me define what is a set first. Okay, I mentioned that a set is basically just a collection. Uh, I should say it is a collection, or you can call it a family. So it's a collection of object, but those objects, they are not the same. Collection of objects, so maybe I call them, they are not the same, so it's distinct. Collection of distinct object. Uh, called element. Those objects, you can call them element, or collection of distinct element if you want. So if you have a bag that that's the set. If you want to explain a set to someone that is on the road, or to someone from your family that hasn't gone to school, that's what I mean by a set. You say that a set is a collection, or maybe you can even say a well-defined collection of distinct element and or object. So that is in the sense. Or you can say even numbers. For those who don't understand object and element, you can say a set is just a collection of distinct numbers. So that is to just say a set of numbers. So for example, if you take your pencil case is a set, and inside the pencil case, there are so many different pencils, there are so many different, let's say, pen, and so on and so forth, let's say rubbers or whatever things that you have. So now let's take an example of a set. That is first as a set. So now, a set generally in mathematics, you can actually also uh, make it something like this with all those things inside. So all those, because there are so many, you call them X. Please, I'm talking of X. Don't start thinking of ex-boyfriends. No, X. If you start, X is the letter X here. I'm talking about. So it could be any of those ones. So that's basically a set. Now I'm going to get a different example now. This one is just a general, which is called a Venn diagram set. I mean, or you can just a Venn diagram representation of a set. Those inside, they are objects. So it could be clothes, could be fruits, could be books. I don't know, any sort of things that put in one bag. Now, let me give an example that we are all aware of. So an easy option of this is the set of real numbers. I mean the set of integers. Sorry, I do apologize. So it's usually uh, uh, given by n. N stand for natural. Why is it natural? Because those are the integers. Did I start the recording? If I'm not recording, please let me know. Okay, so it's recorded. So it's the and stop me every 7 minutes. N start for natural. Why natural? Because those numbers are known to everyone. So those are like 1, 2, 3, 4, 5, 6, 7, and so on and so on and so forth. So those are the set of natural numbers. And then later on, thanks to the discovery by some were in India, then they have included what is a zero. So then this one, you can represent it in two ways. The first one, the set n, I can just call it n. It start by 1, 2, 3, and 4, and then so on and so forth until infinity, where we don't know. And then this one just includes 0 in it. So we could call it n0. Is natural numbers included, including 0. So it's, we can say 0, 1, comma 2, and then so on and so on and so forth. Okay, then the mathematic discovery doesn't stop there. Uh, in Europe, where people have started, and in Asia also, where people have started using the algebra, coming from an Arabic guy called Ali Jabr. So that's where the name has initially started. Then the notion comes for that if you have, let's say, two cows, and those two cows either died out of diseases or get eaten by lions or by any animals or bitten by snakes, then they die, then you don't have those two. So they represent them by using stones. So if the cow is big, they take a bigger stone to say that this is the amount of cows I have, because they used to have cows and all of them, they stay in the same place. So they can distinguish them, but they just to cater the number and to cater for the number and the amount, they usually represent them by stones, depending on is it big, is it a calf, and so on and so forth. Then when they disappear, then the representation later on actually came initially from Asia, but then later on put in context from Europe. So let's say if the number is 2, I have 2 cows initially, and then those 2 cows disappeared. So then I don't have, I throw the stones away. And then basically then say, okay, then the opposite to 2 is then become a minus 2. So initially it was called the inverse. In the addition sense, it was called the inverse, and that name has changed later on. It was called opposite instead of calling initials, because 2 and then what you don't have 2 when you don't have is you have the opposite of that. So which is minus 2, and then that gives birth to the 0, which is 2 minus 2 becomes 0, or minus 2 plus 2 later on become also 0. Then the same. Then from that, then a new set has come up. So you have the set n inside here. Then you have the set n0, which is just it having only the 0 extra on it. But then there's the set z, not Z for Zach, please don't confuse the two. Z is for the set of integers where it contains all those ones that are positive and the 0 that is in it. But then it contains all the opposite also. So which means that you can start from negative infinity, then until you reach minus 2, minus 1, 0, 1, 2, and then so on and so on and so forth. All right. And then with that in hand, the discovery kept continuing. Okay, I need to, have I reached 7 minutes, guys? Have I not? I reached 7 minutes, right?
Not yet.
Okay, because I read the PDF. Let me, I can stop here and then I'm going to start again. I'm going to have to make